Hello students, this is the lecture for Oracle Chapter 10 for COP4710. So in this chapter, we go through basic table creation, referential integrity, and constraints, right? So that's what we're going to be covering here. I set up a temporary database here for us to work with, this UWF database here. This is SQL Server, but it's really the same. It's kind of all the same once you get the concepts. Some syntax may differ, but really not much, negligible if any at all. Okay, so we'll just go ahead and jump right in here. Now this time, so you don't have to watch me type and bear with me, I just went ahead and created some samples here to do what we want to do, and we'll just follow along as we go. So I guess let's go ahead and jump right in. So we'll start by creating a table. COP4710 student is what I call it. So we have like a student ID that's an integer. Okay, and we have a name that's a string, a variable character, right? Okay, so we'll go ahead and create our student. We'll insert a couple of rows into it. We'll insert a couple of Beatles here, Pete Best and Ringo Starr. All right, and let's make sure that our row's inserted. Yes. Okay, so here they are. They both have an ID of 1, 2, 3, and that's a whoops there, right? That can happen if you don't enforce, if you don't have a unique constraint on a column. Of course, you can get duplicates. There's no reason why you wouldn't be able to. So, ID needs to be the primary key. It's an ideal primary key for, say a student would be student ID, right? It's not going to repeat. And so let's go ahead and put this primary key constraint in here. Oh, something I should point out to you. Here we go. So, I just kind of wanted to verify that we had duplicates here, and this is a good query for doing so. So you select account, and you select on your primary key column, and you'll group by your primary key, having count greater than 1, or having whatever column you shouldn't expect duplicates on. And that way you can actually find duplicates. We do this at work all the time if we're having problems, so we suspect that the problem may be linked to duplicates. So just FYI there, this is this is a pretty useful query. You don't have to memorize it, just kind of keep it in the memory banks. All right. So let's go ahead and add this primary key constraint. Right. So I have an out of line constraint here. Notice the syntax: alter table, add constraint. By convention we start these with PK for a primary key, PK underscore, and then whatever the name of the key is. If it were composite, it would be like let's say. Well, actually, it should be ID anyways. But if we wanted ID and name, I could do like that. If we wanted a composite primary key, right? So, okay. So alter table, add constraint, and the type of constraint, and then the column. See, SQL Server is smart enough to know that it can enforce that. If we look at our data, we'll see why that happened. You see, create unique, terminated because a duplicate key was found. Remember, primary keys imply duplicate constraints. So if you put a primary key on a column, it will prevent duplicates. It's a unique constraint as well. Okay. Not only does it enforce referential integrity, it doubles as a unique. So there we go. Note we had 2 occurrences of ID 123, one for Pete and one for Ringo. So I'll just delete Pete. Sorry, Pete. Or to use a line from Pulp Fiction, okay, Ringo, you win. All right, so now it should let me add the primary key constraint to it, right? Yep. Voila. And to kind of verify the constraint, I can go into the metadata, the dictionary tables, if you will, if you want to, kind of correlate it to Oracle. Here we go. PK name, 4710 student. Okay. I'll go ahead and drop it because I want to show it another way, and I need to commit. My go is my commit in SQL Server for batch, anyways. So I'll go ahead and create a table. Create the same table. Okay. Oops. Go ahead and add my primary key to it. All right. And I'll create another table called student grade. It's going to record grades for students. All right. So it consists of an ID, student ID column, section number column, and of course a grade that's going to be like A, B, C, D, whatever. That's why it's only a variable character of length 1. Apparently I didn't delete it earlier when I was playing with this. There we go. So create table, table name, and then inside parentheses, of course, your data, your columns. And all right, so here we go. Here is a composite primary key. All right, alter table, add constraint, and then your primary key. It's on ID and section number. So I just called it PK underscore ID underscore sec underscore no. All right, the type of constraint primary key, and aha, it consists of ID and section number. So you can just go ahead and throw them in there, comma separate them, and that's all there is to it. I think I've already done that, right? No, I didn't, apparently. Okay. So there it is, I created it. And we want to verify that it's there. Yep, PKID section number, there it is, primary key constraint. And let's say we have a third table. COP4710, we'll call it student grade statistics. And I don't know, we'll keep track of how a student does in a class. We'll have all kinds of different, and this is fictitious here, but we have all kinds of different statistics we keep, and what a statistic code that'll be unique. Like let's say it's some sort of a combination of, I don't know, part of their student ID and gosh, the course and some of the statistics. All right, so let's say that this statistic code should be unique. Okay, now since we are linking to student grade, right, because we have ID and section number, okay, that's the primary key on student grade. And since we want to link to student grade, our foreign key, this has to be a composite foreign key. So it has to link to both columns, right, in student grade. And look at how the syntax is. Okay, this is an inline constraint. Before we did out of line here we did a separate statement, alter table, add constraint. Okay, now since this is inline, we just go ahead and put it, convention is kind of at the end. All right, after the last column here, I put foreign key, and then the columns, okay, that are going to be part of the foreign key, references, table name, and then the parentheses column. So this is the table that I'm linking to here, COP4710 student grade. Okay. After you do this a few times, you get used to it. It'll be easy. Okay. So I'll go ahead and create it. I don't think I did. All right, good. So, I said stat code needed to be unique, and oops, we forgot to do that. So here we go. I'll add it now. There we go. So I'm going to insert some grades into student grade. Okay. Okay, and I'll go ahead and add some. I'll add my first entry. Let's say we got this guy in section 123. Okay, there are his statistics, and I don't know. Just for the stat code, we'll say ABC 123. All right. Now we put a unique on stat code in there. Remember, we put a unique constraint. So then we want to add this guy in. Well, I see this is going to fail for a couple of reasons. All right, we see we're going to add this guy in, 333 in on section 444, which doesn't exist over here. Okay, and he'll also have code ABC123. Raggy. Yeah, see, violation of unique key. So we can't insert ABC123 more than once. Right? Makes sense? How about if we change this to ABD123? Yep. So see here, like I said, it's going to fail for a couple of reasons. 333. All right. So here we have. Let's take a look at our definition again here. Okay, foreign key. So we have our ID and section number, right? In student grade statistics, which references ID and section number in student grade. Okay. So we'll need to change this if we want to put student 333. First of all, I had the ordering wrong. So there we go. Now that should take, because I'm using in the foreign key, I'm referring to a valid primary key entry because you have to, right? In other words, see here it says conflicted with the foreign key constraint because it doesn't exist. This row, or well, these two columns, I guess 3, 4, 5, and 3 through 3 did not exist in our table where we get our primary key. So now that I've corrected that, okay, we line up with our primary key. This exists. It refers to an existing primary key, and we don't have a clash anymore because it changes to ABD123. So I won't have more than one value, more than one particular value in a column. There we go. Yep. So that took it. All right, and so let's say we want to make sure that we only enter valid grades in. So on the student grade table, let's say we want to add a check constraint. All right. Now, of course, a check constraint will ensure that you insert values in a certain range, right, from a starting range to an end range, or a starting value to an end value. So here we're going to say, grade is between, CK. I always, by convention, call check, CK underscore whatever. So I name it something meaningful, CK grade AF. So CK, the attribute or attributes that I'm going to put the constraint on, and then what the constraints are, the beginning and the end, the from and the to. All right, and then the type of constraint, and then your constraint criteria. So I'll add this constraint on there. And I'll go ahead and add an erroneous row. All right. This would fail for a couple of reasons. We'll just simplify it. All right. So we are, you know what? I'm sorry. That was wrong. I was thinking that this was the student grade statistics table. So here we go. We're going to try to insert G, a grade of G in there. Yeah, see, conflicted with the check constraint. Okay. What do you think would have happened if we had already had row G in there and then we executed this row here? It would fail, right? Because the check could not be enforced, and it's too smart to do that. It's too smart to be in defiance of itself. All right, let's take a look at our data again. Okay. So create a table called school, okay, and a table called student. Just a moment. Just a moment. Let me take care of these constraints. I'll be right back. Actually, I don't need to go anywhere for this. This is simpler. I just need to drop student first, since student depends on school depends on student. All right, so there we go. So I'm going to go ahead and create a table school, which is consists of school number, school name, and has the numbers, the primary key, which sounds logical, right? Okay, and we'll create a table student, student number, address, school number, which references school name or school number in the school table. Okay. And we'll insert some values, UWF, UF, UNF, and some fictitious students as well. Okay. So I'm going to delete one of the school entries. You know what, we don't want to get rid of UNF or UWF. Let's get rid of, say, UNF. Better. Okay. So now I've gotten rid of UNF. Oh. So I've got an entry pointing, let's see here. Oh, I already have those rows inserted. Okay, so that's on school, and student was inserted. Okay, so I'm going to go ahead and delete UNF from school. I can't, right? And it's because of this guy here. So you can't, if you have a foreign key, by default, Oracle and SQL Server, I believe MySQL too, also have on delete restrict set. So what that is you can't delete a primary key that has a foreign key, a child foreign key, depending on it. Okay. So in other words, I would have to ask this student to be able to delete the UNF record, because this primary key is pointed to by this guy, by student, so student 333. So we'll try something like this, and we'll try it again. Delete from student where ID equals 333. What did I call that? Student num. Okay. I got confused with the first example we had. Now I should be able to delete school. Cross your fingers. Yep, there it goes. Get rid of tables. Get rid of the student table, because we'll do it a little different way here. All right. So now I'm going to create table student the same way. Only notice here on delete cascade. So cascade says that if you have a primary key with foreign key children records, and you delete that primary key, it will go ahead and delete all of the foreign keys, and it will do this iteratively. Okay, so it'll delete every foreign key that depends on that primary key, and every foreign key that depended on that other, that first level foreign key, and so forth ad infinitum until it's done. So let's see this in action, then we'll kind of get a better picture of it. Okay, so create another student table, insert records. Let's see here. Number 3's not. I can't insert number 3 because he's not there. Let's see. So we will add the record back. Again, we don't want to delete UWF. We'll delete UNF. So now what happens? Okay, on delete cascade. So we shouldn't get. It's not on delete restrict. So we shouldn't be barred from deleting this. It should simply delete the dependent row, right? Good. Okay, so we deleted school number 3. Now what we'd expect is that since this student depends, since the record depends on school number 3, UNF, we should expect this row to not be there anymore. That's right. See, we just inserted him, but now he's gone because we deleted the school on which he depended, and we have cascade mode set. All right, so that's kind of a clear example there. And then here's another one. We have on delete restrict, on delete cascade, on delete set null. Same syntax here for SQL Server. So we'll go ahead and drop student table and recreate it. All right, we're recreating the student table with on delete set null. We'll insert our student records into it. Yeah, number 3 I can't because I have to, here. There we go. Now that I've inserted the school, I can insert the record on which it will depend. Or, well, I'll insert the record that will depend on UNF. Okay, so now let's see what happens when we delete UNF. We would expect this column in this row to go null, right? So we should have our school num be null for 333, for student number 333 after this. Let's give it a whirl and see what happens. Yep, there you go. And that's all there is to it. As Forrest Gump said, that's all I got to say about that. So, this is pretty straightforward stuff here. It's not really complicated. The foreign key, primary key, really is the referential integrity is pretty easy concept as well. So if you have any questions, just of course ask. But otherwise, I guess I'll see you at the next lecture.